Hello and welcome to another video on the React Native Introductions, a course taught by Kadi Kraman, a software engineer with holds a background in mathematics. Then she moved on to the software field, the computer science, and she previously worked at Formidable, a social first creative agency, as director of engineering mobile services. And right now she is working at a software developer at Expo, something that we're gonna take a look in this course. So the goal of this course is for us is to learn how to build React Native applications, their mental models, and the concepts that differ the React Native from the web. This course is for JavaScript developers who are new to the JavaScript or to this particular JavaScript framework, React Native. And if you're familiar with React, all of those knowledge are easily transferable to React Native. A little bit of introduction here. In today's video, I'm gonna make a quick recap of this introduction, as well as the setup, the basic components, and then we're gonna focus our attention to lists. How can we render lists and how can we use that particularly UI component? So the first things first is the introduction. Is as a way to know what are the things that you need to have, especially you will need a Windows, Mac, or Linux machines, as well as an Android or iOS mobile device. And as a way to understand this React Native, uh, it is important to recognize that these devices right now are capable to process 100,000 times and have one more time ran than the leading computer or the guiding computer uh, from Apollo 11 that lands the first human to the moon. So why am I mentioning this? This is something pretty crazy because in the past 50 years, look at how all of this thing has evolved in a way that now we can have this powerful device that when we need to browse the internet, this interface that is small, as well as it has a small screen and a small interface to interact with, it makes the browsing the web a suboptimal experience compared to the desktop or the laptop. So, because the idea here is to build applications for these mobile devices, we need to look at what are the market share, especially in the iOS and the mobile iOS. And the TLDR is that 70% of worldwide mobile OS market share belongs to the Android, whereas the 28.40% belong to the iOS. So the idea here is to recognize that you want to target is 100 or at least 99% of your audience. So because of that, a you need to actually is um, build applications that are capable to run in these two main platforms, Android and iOS. You'll have these two different workflows because those two different OS, first, they use a different language, and second, one application from one platform does not work on the another, right? So because of that, you will need to have two different workflows. For the Android, that is going to you need to know is how to write applications in Java or Kotlin, and for iOS, you need to learn Object-C or Swift. All right, and this is something that is quite tedious because now you have to look at two different code sets and keep track of features and bug fixes, that kind of thing. So companies like Facebook decide to have a go at solving it. And when they did that, they come up with this particular framework, React Native, using one single language that simplifies the code base by having just one code base, one language, one workflow, one development team, which helped them to reduce costs, as well as the easily extensible or easily extensible functionalities. So, with that, that's the reason why React Native emerged. So, because with React Native, and I'm quite biased with this, with React Native, uh, unlike other solutions, when you have all of these tool sets, if you want to do something outside of that, you're on your own. You're practically lost. But with React Native, for example, if you want to extend the functionality of your application, you can easily go to the native code to actually build that wrapper in React Native that can be accessible across devices, Android and iOS. So, with that, uh, I also look at how that works, the mechanism of how React Native works. And React Native is built to target existing compilers, which means that it will target is, and that makes a lot of sense. It will target it will target these existing compilers like the Android compiler or the iOS compiler, Windows, or React Native VR. So they recognize that instead of having to create their own compiler, they're going to reuse is the existing one. So they're not going to reinvent the wheel. So with that, then we look at now at this the trade-off of using React Native. Okay, and the first is or a couple questions. First is for Kadi experience, what has been the features when she have to implement that she need to that has been hard for her, uh, and she described that, for example, plat payment integrations that are new to the platform, that's when you have to go out to the React Native and do the hard work with native code. It's not that hard, it's quite straightforward. The documentation help you to do that. And the other is, for example, for email providers, for third party email providers, particular them. Another question is that how about performance? Which feature do we need to stay away for performance penalty? Because React Native is using Hermes as the compiler or as the engine. What it takes now is uh, yeah, Hermes. What it takes now is JavaScript, and I'm assuming that uh, in compact bytecode it features ahead of time. If you're only interested in using pre-built, Hermes is new or existing React Native app. You don't need to follow this guide. But Hermes is this JavaScript engine. Okay, is this JavaScript engine for fast startups of React Native apps. So, um, Allegedly, and according to her, as you can see, this is something developed by Facebook here. You can see now they renamed that as Meta, but now they have Facebook here. So, um, as you can see here, this is React Native here. So they must have some bindings behind the scenes for that. They must have this exactly. Even though they're telling you which are the target that they are, the mobile iOS they target, the iOS 13 and Android 6. Actually, it's quite old, by the way. The code of conduct and that kind of thing. So, because of that, they use is this, right? They use this Hermes as the JavaScript engine for fast startups in React Mobile. So then we look at something that is widely used, especially in the React Native ecosystem, which is Expo. If you never heard about that, don't panic, don't worry. This is just a suite of tools built around built around and for React Native. So the idea here is to improve the or the developer experience. So it is all about developer experience. This is a separate entity from Facebook. They don't have any affiliation. So some people can be have strong opinions about expos, but the thing here is that with expo, especially if you're new to this allows you to speed up the process of knowing of writing your React Native application. So you don't have to worry about having to configure your environment for Android or iOS. Uh, and so Expo on physical devices is the quickest possible way to get going. One of the limitations of Expo is that, for example, if you find yourself in the need to build something that is outside of Expo or React Native, you need to you need to do something called ejecting, or let's see if that actually is still relevant because when Kadi Kraman mentioned that, she described that at 2020, 4 years old. Okay, and even though there's still that uh, thin, uh, so if you need to go to the native code, you will have to eject your React Native application. So that's great. That's cool because that setup process that Expo actually speed up, it can take you up to 2 hours to do that. And when she mentions that the vast majority of applications that are in production that she has built or worked with, that start with Expo, most of them end up being ejected from that. So something to consider that. You might start using Expo, but at the end of the day, you will have to set your own configurations uh, for that. So then we look at this, the setup. How can we use that? We can use that using Expo or the EAS, which is the Expo Application Service. Even in the documentation, they tells you is that how is the development process. So you get an idea of the mental model and the development loop, the Expo router, some of the particular navigations and helper functions, the Expo model, uh, like well adding or removing existing functionality in the Expo model, and the Expo application service. So you can deeply integrate cloud service for Expo and React Native. That's great. That's interesting. Uh, and then how you can start to use React. How can we finally write code? If you're gonna go with Expo or any React Native application, the development here is they're going to bundle your JavaScript code and send over the local Wi-Fi. So your device, your physical device, if you want to connect that, must be in your local Wi-Fi. Also, a word of linters, something that we're quite familiar with, yes, lint breeder and auto fixing we use in this particular case is some of the recommended linters like React Native, okay, as well as the debugging. How you can improve is the debugging using Expo Go, right? If you're using that, you might look at two particular features, which is reload and OpenGS debugger through the Google Inspect. They also provide you, for example, here, let me actually do something pretty quickly. React Native here, exactly, React Native here, hmm React Native here, React Native debugging, uh, Re- React Native debugging. There you got it. Debugging basics. Okay, this is how you can debug in your application. And as you can see, is that or device or shake. Right. This is how you can actually enable is the uh, sorry the debug menu. So exactly. So this debugging comes from React Native. You do is this. All right. So here the using is something called like something called Flipper. To native is a native debugging tool. Provide JavaScript debugging capability for React Native. The embedded Chrome dev tool. It is funny because this is something that is deprecated. Debugging React Native apps with Flipper is deprecated in React Native 0.73. We will eventually remove out-of-the-box support for GS Debugger via Flipper. Just so something that you take notes. Okay. Uh, Now the one is to use is the Hermes debugger, the JavaScript engine for building and ship fast startups in React Native app. And then you got is the new debugger here, the experimental, right? Okay, cool, cool. So it means that if you're going to go, if you want to use Flipper, it's actually deprecated. Uh, Better go with the Hermix or Expo for that. And yeah, especially on the debugging. Especially on the debugging, preferably go with the Expo or the Hermes debugger. Okay, that's good. That's cool. And now, finally, after we look at that introduction, okay, of what is React Native, what is Expo, what is the trade-off, as well as uh, understand the the React Native ecosystems, what are the things that are that will be helpful for improving our developer experience by adding a linked herd, as well as understanding the debugging. Okay, because this is where you're going to spend most of your time as a developer, right? So debugging and reading someone else's code. So this is it. Okay, basic components. So remember that after all, React Native is allow you to access through the mobile or to the OS platform API through JavaScript, as well as the appearance and behaviors using React. Okay, this is the two distinctions as a way to make yourself familiar with that and describe that. So, because if you come from the React world, from the mobile application, from the web application, you're gonna see that a lot of these features actually they are global. Whereas in React Native, you have to import each one of those features, especially the UI and uh, other features. So first, we're starting with this UI elements. Okay, the basic UIs. For example, view, which is act like a div on the web. Scroll view, you have to indicate that this content is scrollable. Text, as well as styling. So unlike the web, uh, style is done by style is styling is done by inline style here. Yep, styling is done by inline style, so you can forget about CSS cascading and that kind of thing. So Kadi create something here, so you need to actually import all of those features. Remember, all of these features in React Native, you have to absolutely import them for that. So here we look at the safe area as a way to show content in this safe area, usually useful for iOS. Okay, and we started to define is our style sheet object. Style sheet.create. You put that at the bottom, and then as a way to get access to that, you indicate to using the style property per component what will be is the particular style that you want to give to that element, to that UI. So far so good, right? So far so good. Padding top, padding additional. There's subtle things here as a way to change that, especially when you want to talk about positioning like this. You can also practice positioning because this is heavily in, so this is using Flex. And if you're not familiar with Flex, this is the great time to have fun with it. So this is Flex. They're using Flex behind the scenes, and you can even inject your own style here. But the thing here is that by using is the style sheet object that they provide, it performs some optimizations uh, for you. So it is better to go with the style object rather than to inject your own style. We can also pass multiple styles here, and they're going to override with the latest style in your array. And I work on fonts. So what if you want, for example, a particular set of fonts in one component and another? So it's going to depend on what you want. But one approach can be is that having one share, having one, sh- having um, having one big or one share, or having a common big style that you can import styles from, okay, as an object, and the other is have a component that you reuse in every single place. So this is two approaches, especially when you want to now use some funds in some components and define a global style in one component. So because he was talking up more about is the architectural design, something that is very, very important. The thing here is that, okay, what are we gonna do here, and how can we organize the code here? So you have this particular two approach, especially if you want to work with reusable class and fonts, or you have a big style sheet here, okay, that you can uh, import into another component, or you have it one component that is reusable across different views. And then we look at a particular exercise of how can we style our components as well as the componentization and how React uh, is a component-based framework. That means that you can go by little, like Lego blocks, and then you started to create more and more bigger things. You started from molecules, or you start from atoms, molecules, pages, uh, layouts, and websites. So the thing here is that every time you build a component to make it simple to test for the first time some contents to show. This is something that she mentioned. Okay, exactly. So every time you build a component, make it easy to test for the first time with some content to show. This is more for like testing. So the idea here is that as you starting to develop your components, um, do that one step at a time, or are the things that you want to implement, like Lego blocks, and then you can figuring out what's going on. Uh, and because this is using is um, this is without components, all right, all of this, and this is when we end up having component base. As you can see, it's way much more cleaner, which is 41.53 less code, at least for this component, which means that less line of code to read, much more easy to maintain, test, and debug. So that's something that we are quite familiar with. Okay, it's also important to recap about those particular concepts as we move on, and then okay, today we're going to take a look at list exercise and solution. So I'm going to take some notes out of the Kadi Kraman course. So you're not going to see what I'm doing. Lines, let's write lines here. Yep, you're not going to see what I'm doing here. Lines here, and there you got it. So this is components and lines. All right. Lists, not lines. Lists. Exactly. So this implementation of color is quite decent. But what if we have 10 or more color box? So here we're talking about is how can we handle with scalability? What if, okay, mm-hmm, 10, 100, or 1000. So this solution won't scale. And that's the job of software engineers, is to try to make, or the computer science, is to try to make those solutions scalable. Is to try to, once you find a particular problem, okay, yeah, once you find a particular problem, and when that problem happens over and over and over, you want to find a solution that can fit as many use cases for that, or that field is, or that give you a technique to actually be more straightforward with that. An example of that, that's a good example, is that how, what is the sum of the first n odd numbers? Which means that what is the sum of the first one, of the first 5n odd numbers? 1 plus 3 plus 5 plus 7 plus 9. Okay? So instead of actually having to compute each one of them, okay, what you can say is to find a way, a particular expression or a formula, an algebra, a generalization that help you to, anytime you find this particular problems, you can solve them quickly. So here, instead of actually compute each one of them, we can say, hey, how many numbers do we have? 5. Let me now using a particular equation, multiply that by 2, which is by itself twice, and the outcome will be is 25. You may say, hey, what the is this? What kind of sorcery is this? So 1 plus 3 is 4, plus 5 is 9, plus 7 is 16, and plus 9 is 25. So the idea here is that by looking at this simple example, it is time to now say, how can I abstract this to other solutions? How can I do that in other places? Okay. Uh, and for example, because we're looking here at lists, or a thing that is repeating over and over and over, because remember, too much abstractions is the enemy of the good maintainable code. Once you see something that is repeat 3 times or more, it might be a candidate to create an abstraction. In any case, but this is the idea here, is that, hey, this is not scalable, so we need to find a way to make it scalable. You may wonder, how can I find that? When can we find that? By how other people have done, okay, by looking at reference, and also with the help of mathematics. Because the mathematics, the course of mathematics, is from the root, the mathema, or the mathematic, which is the Greek word. It can be translated as what one, what one gets to know. And that's something beautiful. At least to me, it's like, you, as long as you have your capability at nearly 100%, uh, it can take sometimes or not to others. You can learn this thing. So when you take a look here as the mathematics, okay, as the mathematics, the mathema here, which is the Greek word from mathematics. Okay, is mathematic. Okay, and is this. But as you can see here, from Greek mathematik, techne, which is the mathematical science, feminine singular mathematicus, all right? From mathema, a lesson, it's like the science knowledge, mathematical knowledge, a lesson, literally that which is learned, you know, is something that you can learn, that which is learned from that, from mathenein, to learn. So the word mathematics from the mathema, um, which is the Greek word, uh, it comes, so it means is that which is learned, what one gets to know. That's beautiful. That's not reserved for a few elites of people. The only thing is that, again, some people are now more inclined or easily captured by this, where others take a little bit more of time. So, Liz, okay, what happens when we have this particular problem is repeating over and over and over and over? So we need to find a way that make this scalable. So that is list.
Wooden scale. Now, if you're familiar for how we do, um, how we render these things on the web, you might be tempted to have a color array and just map over it to render a bunch of colors.
So the point of mentioning this, okay, is as a way to describe. It's also helped me as a way to refresh all of these things, but also as a way to use that example that I give it to you in your real life and see how that actually works, and how you can make that work in your real life. How that makes sense, not only in your profession but also outside of it. Please don't kill people or kidnap them. Uh, I know that sometimes that you want to do that. I don't encourage. I don't encourage. But yeah. Anyway,
In native development, how we render these things on the web, you might be tempted to have a color array and just map over it to render a bunch of colors. In native development, you should never use a map to display an array of items.
interesting. Very, very interesting. In web development, okay, you can use a map to display an array of elements. Exactly. So in web development, you can use a map to display an array of elements.
And this is due to performance.
Exactly. In React Native, you shouldn't use map due to performance.
Because basically the mobile phone will render every single thing that's on the screen. So if you have an
Basically, because the mobile,
this
okay,
is due to performance. Because basically the mobile phone will render every single thing that's on the screen. So if you have an array of like 100 colors, it will try to render all of them. I will try to re-render all of them whenever the component re-renders, regardless of whether the data has changed. So in order to render,
this is a very common mistake for newcomers to React Native. While it may be fine to do on the web, uh, in React Native you should avoid use map in the render. This is because mapping over an array is not optimized. hmm Okay, it is React Native. You shouldn't use due to performance. React Native will attempt to render every single element in the array all at once, regardless of whether they are visible on the screen or not. Interesting. Okay, React Native. Mhm. React Native will attempt to render every single element in the array all at once. React Native will attempt to render all single elements, all single element in the array all at once, regardless of whether they are visible or not on the screen. Oh my god! Regardless, regardless, regardless of regardless of whether they are visible on the screen or not. Mm, and there are special components uh, in React Native to do that, or for rendering lists. And if you remember, rendering elements and forms are by far the Jesus is the 90% of things that web developers do. Right? Rendering lists, show a form, and forms. Exactly. hmm For rendering lists. So these are flat lists and section lists. Flat lists and section lists. Okay. So let me take a look now at the UI interaction here. So far we have a look at the styles, okay, the height and width, and how you can use that. Instead you use exactly percentage dimension, layout with flexbox, exactly, exactly. So there's some limitation of that, and now gesture responder, handling touch, networking, security, accessibility, where in the F is the native model, UI and interaction, color reference, interaction, navigation between screen, animations, gesture response, connectivity. Okay. Testing, debugging, native models, um, Android iOS and guys, experimental. What in the UI and interaction. What the interaction? Handling touches, navigating between screens. That's interesting because here it's not talking about rendering lists, color reference. Okay, why not? Handling touches, navigating between screens, animation gesture responder system. Okay. Can you provide me yeah, the components here? Okay, we're looking is at the component. That's interesting. That this is not included in the guide. Anyway, core components. Yeah, core components, prop and object types. So this is all of our UI, Android components, and iOS. It's pretty much like you're working with Bootstrap or Material Design. You'll get used to it. So you get flat list like this, flat list or section list? Okay. Mm-hmm. All right. We got okay. As also, this is for me to make myself familiar with this. And this is section list, and then you got flat list like this. All right, and then you got it. Okay, this is in the core component. Makes sense. Move on.
We have special components in React Native that you can use to display them. And these are called flat list and section list. So whenever you have an array of data that you need to display, you should probably be using one of these. I refer to these this documentation quite a lot. So this is the React Native documentation for flat list and section list.
Damn, some back then they were using is 0.61.
And on the right, it has all the properties that there are available, and same for section list. I'm going to go through some of those in a bit, but let's look at how it works first. There's a lot of configuration options for flat list, but at a minimum, you need to give it 3 props. The data, which is the array of items you want to move over and render. The render item function, which is the property that you pass in a function that tells the flat list how to render each individual item.
Okay, the render item is is passed is past the item and it is indexed. I would return individual item component.
Render. The render item function, which is a property that you pass in a function that tells the flat list how to render each individual item. And then the key extractor, which basically gets each item and you have to return a unique index for that item.
So this is so flag lists need a configuration. Okay, so look at here, flat list. So flat list need some sort of configuration. So flat list need, and the question is that a performant interactive for rendering basic. Okay, and the other is not performant. A performant interface for rendering section lists, supporting the most handy features. Mm-hmm. Okay, pull to refresh, scroll load. Okay, this is all the features that it allows you to access. Fully cross-platform, horizontal mode, configurable viewability callbacks, header support, footer, separator support, pull to refresh, scroll loading, scroll to index support, multiple column support. But this is a bunch of features. Yeah, a data render item and key structure. Okay, so this actually requires exactly the render item and the data. And if you take a look at the section list, it actually needs that as well. The render item actually accept is a section list, the render item, as well as the section, which is the data here. Mm-hmm. Mm-hmm. Interesting. Interesting. Okay.
So you can go ahead and click on this if you want to play around with it yourself. But this is an example of flat list that I created on Express Mac, which usually appears here. It doesn't at the moment. So Expo Snack is basically like JS Fiddle, but for React Native, which is pretty cool. But it's a little bit busy. Yeah, it's a little bit busy, which is pretty cool. But it's a little bit busy. Yeah, it's a little bit busy. Yeah, okay, there we go. So, so this actually renders on the web, so you need to be wary of it. It's not actually how it will look on the phone sometimes. If you want to display it on a device, you can just press here and like scan the QR code. But I'm just gonna look at the web one because I don't care for this one. All right, let's look at what it looks like. I don't think I can make it smaller. Well, hopefully you can. Let's do it. Yeah. Right. So this is my app, and the only thing I'm returning from this app is a single flat list which I've imported from React Native. Now I've got a data which is an array of fruits. These are just the names of the fruits, it's an array of strings. And then for the key extractor, like it gets past the item, which is whatever this is, which could be an object. And then I need to return what's the key for that item. So this needs to be unique. This actually also has the index. So if your item doesn't have anything unique, you can use the index as well as symbols in the item to create something unique. And then the main thing we have here is the render item, which is basically a function that takes the data element where data.item is one of these elements. So usually you actually end up doing this and destructuring, but it can be a little bit difficult to read when you first look into it. And here I've got a food component, which basically just has a view and a text that renders the food name.
Exactly. So the idea of this is to say something like this. So because flatnet needs some sort need a bunch of configuration. Okay, and that is um, the data, the render item, the render item, and the key extraction and the key extractor. Okay, data, key extraction, and render item. Okay, the data, well, data used to be display, the key extractor, a function that must return a unique a unique value. This is more like for React Native, okay, as a way to keep track those elements and do that in a performant way. And the other is that render item, a function that tells a function that tells uh, how each one how individual elements will look like, how individual elements will look like. So if you want to take a look at that example here, is this. So here we are exporting instance in the safe area, a flat list that is the data that we want to render here with a unique ID, you know. On the key structure, we say, hey, we're going to return is this item ID, and on the render function, which would talk into the flat list to say, hey, you know what? I want you to show this. I want you to show each one of those elements like this. That's interesting. That's very, 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 very interesting. Yeah. Okay. Hmm. Let me actually here is uh, do this exactly, and there you go.
And flat list and section lists are actually very cool in that they are completely optimized for the web. If you have like 1,000 elements in your array, it actually only renders the ones that your user can see. Optimized for the web. If you have like 1,000, and flat list and section lists are actually very cool in that they are completely optimized. And flat list and section lists are actually very cool in that they are completely optimized for the web. If you have like 1,000 elements in your array, it actually only renders the ones that your user can see.
Okay, so flat list and section list renders the elements that the user can see, or the viewport. Exactly.
Let's look at the section list example as well. Alright, so this is very similar to flat list, and it actually shares some of the properties. The difference here is that we can add a section header in between a bunch of the items. So instead of data, notice that the property we're using is called sections, and the the data element is an array of objects where I've added a title. It doesn't have to be called a title, but the only key that you really need is data. So this has to be an array of objects where one of the keys is called data, and the data is basically the content that gets rendered in the section. The key extractor works the same, but notice that the keys don't get extracted from this, they get extracted from this. So that the item that you get is, for example, apples and broccoli, and not this entire object. Then we have a render item, which works exactly the same as in the flat list. And finally, something that we don't have in the flat list, we have a property called render section header. And this basically gets the section, in this case, the whole section, and we use this to display the title. Now, section list is handy because if you use it on the actual device, the sections actually are sticky, so they stay on the screen until you pass the section. Yes?
So section list only works with array of objects.
Yes. The data is basically the content that gets rendered in this.
Okay.
Which basically just has a view and a text that renders the data. So this has to be an array of objects where one.
A very important distinction. Note. Flat list and section list. Difference. Flat list.
One of the keys is called data, and the data is basically title. It doesn't have to be called a. And here is that the key extractor. This has to be an array of objects. It works the apples and broccoli that we don't have in the flat list object. These content we call it, and the the data element is an array of objects where I've added a title. It doesn't have to be called a title, but the only key that you really need is data. So this has to be an array of objects where one of the keys is called data, and the data is basically the content that gets rendered in the section. The key element. Alright, so this is very similar to flat list, and it actually shares some of the properties. The difference here is that we can add a section header in between a bunch of the items. So instead of data, notice that the property we're using is called sections. They get extracted from that we don't have in the section, and we using it property, user can see. Let's look at the section list as some of the properties. The difference here is that we can add a section header in between a bunch of the items. So instead of data, notice that the property we're using is called sections, and the data the data element is an array of objects where I've added a title. It doesn't have to be called a title, but the only key that you really need is data. So this has to be an array of objects where one of the keys is called data, and the data is basically the content that gets rendered in the section. The key extractor works the same, but notice that the keys don't get extracted from this, they get extracted from this. So that the item that you get is, for example, apples and broccoli, and not this entire object. Then we have a render item, which works exactly the same as in the flat list. And finally, something that we don't have in the flat list, we have a property called render section header. And this basically gets the section, in this case, the whole section, and we use this to display the title. Now, section list is handy because if you use it on the actual device, the sections actually are sticky, so they stay on the screen until you pass the section. Yes?
So section list only works with array of objects.
Yes. Yes. They both need to have an array, but for section list you have to have an array of objects.
Flat list. So section list use an array of objects. Flat section list use an array of objects. Flat list only a single array. Section list allow you to add section headers and display. Exactly, section lists allow you to add section headers and control how it will look like.
So I've just listed some of the properties that flat list and section list have that are used most frequently, so you might want to look into. Firstly, we have property section list. You have to have an array of objects. So I've just listed some of the properties that flat list and section list have that are used most frequently, so you might want to look into.
Okay, list props. In section list. So sections list has now exactly sections, an array of objects. Okay, an array of objects. Key structure. The same as flat list. In render item, render item, and render section. to tell how each element will look like, how each section will look like. hmm You have now this fine control tune, this fine tune control. This you have now this fine tuning. List prop, list props. Okay, so you got now list props. List prop most used by Kadi Kraman. Kadi Kraman. Exact.
Firstly, we have the item separator component. So this is you can pass in either a function or just the JSX component, and it renders a custom separator between your items. So for example, if you have a line or some kind of image or something custom that you want to render, instead of adding it underneath each item, you can use this item separator component. Then there's like
Okay, item separator component. Item separator component. Okay. Item separator component. Interesting. Item separator component. Okay.
a list empty component. This is actually really cool because if we did list empty component, and I'm just going to do a text that says list empty.
Oh, is when something is not present.
And now instead of food, if I pass in an empty array, it will automatically render the list empty component.
It's like a
So this is really
default.
handy
It's like a
for
fallback.
because you don't need to
Mm-hmm.
worry about going, oh, if this stage is empty, then render this, otherwise this. All you need to do is just add this list empty component.
Interesting. List empty component. List empty component. Okay. List empty component. Okay. Useful for data fetching on loading scenarios.
Then there's a list footer component. As you might imagine, this is something that gets rendered at the very bottom of your list, regardless of how big the list is.
Exactly. List bottom here. List footer component. List footer component. List header component. Exactly. So list header component. Mm-hmm.
So I'm going to add this back. List.
List footer component. List footer.
Cool. Yeah, so this gets at the bottom of the list. And then there's an equivalent list header component. So I didn't add a safe area view here, which is not good of me. I'm going to add one quickly. Scrolls, but the list header and the list footer scroll with the content. Whereas if I added a bit of text outside the flat list, yeah, then this bit doesn't scroll. So this is something to bear in mind because sometimes you might want to have the header, like just one thing be sticky in this case, You don't want to use the list color. Another property that you'll probably not use every day, you'll definitely not use every time, but it's good to know, is the extra data property. You can pass anything in there. It can be just a single item or an array. But basically, the flat list only gets re-rendered if the data changes. So if the render item function that you have renders different things based on something in your environment that's not the data, you'll have to put these things in the extra data. So that's something that might save you some hours of debugging. I wish someone had told me before. I spent hours on this. Another thing.
The list only gets re-rendered if the data change. The list only gets re-rendered if the data change. It might happen through that what you display depends on some external factor. In this case, use extra data to pass in any variable that should also trigger a re-render when changed. Here we go. Extra data like this. A markup property for telling to the list to re-render since it implements pure component. If any of your render items, header, footer, functions depend on anything outside of the data prop, stick here and treat it immutable. So what she mentioned here is the extra data. What she mentioned here is something like this.
So that's something that might renders different things based on something in your environment that's not the data, re-rendered if the data changes. So if the render item function that you have renders different things based on something in your environment that's not the data, you'll have to put these things in the extra data. So that's something that might save you some hours of debugging. I wish someone had told me before. I spent hours on this. Another thing, I think someone asked this on the chat, which is can you render things horizontally? And Flatlist actually has a prop called horizontal, which takes true or false, and this renders the list horizontally rather than vertically. Another thing that's cool is that it has a num columns property, which I think if I just do num columns true, yeah, it just renders these in a column, which is so handy. Because on the web this is a chat, so you can pretty much make this any amount of numbers.
Nums column. Names. Nums column. Okay. Column. Multiple column support, but this isn't exactly. Okay. Flat list only. Multiple column support. Extra data. It seems that she used vastly flat list. List data, extra data, and num column. Num column. Very handy prop. Only in flat list. Okay.
And finally, on end reach, this you can pass the callback here, which will get fired when the user has scrolled to the end of the list.
On end reach, and this is an event. On end reach, on refresh, but I think that is no longer used. I think they deprecate that for that section list. Yeah, I think they deprecate that on end reach. But this is some virtualized list. Exactly, this is some virtualized list. Virtualized list. Okay. Virtualized list. On enrich. On enrich. You can pass a callback here. Exactly. On enrich. To pass a callback. Exactly. To pass a callback for this. To pass a callback for example, refetching data. Refetching data. That makes a lot of sense. Exactly. Refetching data once the user is near to the bottom. Only in virtualized lists.
And this is handy for if you're doing data fetching, if you have pagination, so you'll know when to paginate. There's also attributes that let you customize when this gets triggered, like how far in advance you need to know.
It seems so. Oh my god.
Now you know everything there is about flat lists. Let's put this into practice. These colors you might have already recognized.
Alright. So, that'll be all for this video. Take care. Bye bye.